viewers, my name is Abongile Mbusha from Ulwazi High School. Welcome to the ECDoE broadcast studio. Now let's make a recap now from the first lesson, that is whereby we had an object that was thrown, so what was dropped from a certain height downwards. Now we're going to continue now to a second scenario whereby now an object is thrown on a certain height downwards. Okay, so for an object now that is being thrown, that is downwards here. Okay, so on this one, we're thrown an object downwards. Definitely we're at a certain height. Remember, that is if you're on the ground, then you cannot throw something that is already on the ground. Okay, so that means now you cannot throw downwards for something that is already on the ground. Okay, so on this scenario number 2, if the object now is thrown, that means now the velocity now is not equal to 0, or the velocity is non-zero. So that means now we have now a certain initial velocity now on this case now. Okay, so we'll look at the scenario here for an object that is thrown downwards from a certain height above the ground. Then the initial velocity, as we said, that now is not 0. Okay, then the object accelerates downwards, and the net force is also downwards here, because that one, this net force then is that is our weight there. That is the only force that will be acting on that particular object as it goes down. So if that is the only force that is acting there, then we're going to regard that one as the net force. So that now, as we know, that is the weight is always going downwards. So the net force is also going downwards. Then, and the motion of an object that is going downwards. Okay. Now let's see, that is to the next slide then, so that we can get the gist out of this lesson. Okay, so now on this lesson here, we're given a graph. As to analyze the graph, a velocity versus time graph. So if we're given that is now a velocity versus time graph, okay, remember now, as I said now, here we must know that is we're having, that is the time in seconds. That is on the x-axis. We're having the time in seconds. So far, out of the 4 variables that we've been talking about on equations of motion here, now, if you are noting here, we're having the time already, we'll have it on the graph, and also the velocity. So that means now on the graph, we already have 2 concepts here, that is velocity and the time. So the one that is left now is going to be the acceleration and also the displacement. So those are the both that are missing on this graph. Maybe that is the examiner will want us to determine. Okay, so now let's focus now on the concept that now we need to be addressed on this type of a question. Okay, so also the most important part before we go to the calculation here, we must now be able to choose now which direction there is being given as positive. Okay, so now if we're given the graph, now on the graph they have already chosen for us on which direction now they have chosen as to be positive. Remember, below them, time axis here, we're having a negative velocities. Then above our time axis here, we're having what? A positive velocity. So now our graph now is occurring now above the time axis there. So that means now on this scenario here, up is taken as positive. Sorry, okay, sorry about that. It is downwards, not up. Is downwards, not up. So here they have taken down, but this ball is thrown downwards. So that means now our down is taken as positive. Okay. So now by analyzing this, we could see, remember then on the y-axis here, if we're given velocity versus time graph, then if the graph now touches, that is the y-axis, the y-intercept. So your y-intercept there is going to represent your initial velocity. So that means now our initial velocity on this case now is given as 10. Okay, so this graph at this particular point here, it is now hitting the ground. So you hit the ground at a velocity of 20. So that means now it's from 10 up to to 20. So that means now the velocity is increasing. As we said that now, for any object there, if it's going downwards there, the velocity will increase because they are moving in the same direction with them gravity or the force of gravity. So the velocity is supposed to increase. Okay, its kinetic energy is increasing. Okay, so now I think we're done with the first one there. Then our down is taken as positive. Then now, okay, say now write the initial velocity of an object. So the initial velocity of an object then is given on the graph. That now we must be able to analyze the graph. So on the graph here, that means now that one is going to be our initial velocity. On velocity versus time graph, remember the y-intercept. The y-intercept is equal to, the y-intercept is equal to your initial velocity. Sorry, it's not zero, it's non-zero. So it's going to give you, that is your initial velocity there. Okay, so now as to answer this question here, that is right, the initial velocity of an object then. So our initial velocity there is given to be 10 meters per second. Okay, so that now we got that one from our y-intercept then. So the y-intercept represent our velocity. Okay, then now if we go to the second one, okay, let me just tick so that we are done with these ones here. Calculate now the time it took to hit the ground. Now we want now the time it took to hit the ground. That now the time at this particular position. Want the time at this particular position. This is the time in seconds. So we want the time at this particular position. Okay, so now if we want to calculate the time, we must also ask ourselves there, what do we know? So which variables do we know there in order for us to go and choose, that is the direction here. So now, if we are to create a data, on the velocity versus time graph, they were given the initial velocity. So the initial velocity is 10 meters per second. It's going downwards, so it's supposed to be positive. And also the final velocity is given to be 20 meters per second. So it also is positive, but it's going downwards. Then now, also we know that is the G or the acceleration. Our acceleration is given as 9,8. Is given as 9,8. Sorry about that. It's given as 9,8. Is given as 9,8. Okay. There we go. Okay. So it's given as 9,8 meters per second squared. Okay. So also positive because our G is always going down and our down is taken as positive. So that means now we're good to go because we know all the three concepts here that is we're supposed to know. Then now the question now is asking us to calculate the time it took to hit the ground. The time it took to hit the ground. So now by having 4 variables. So now this ones here will allow us now as to choose which direct equation of motion that is you can use out of the 4. Now, if we're given that, or that's the equation that is now we're supposed to use here. So we must know that is the final velocity there is given as 20, which is equal to our initial velocity is given as 10, plus our acceleration is 9,8 t. Then want the time. So if we were to transpose that is the 10 then to the other side, so it's going to be 10 minus, then you change the sign. So on 20 minus 10, which is equal to 9,8 t. Okay. Then now it's going to give us 10, which is equal to 9,8 t. Then we divide both sides by t. So our t will give us, our t is supposed to give us 1,202 seconds. So that means now at this particular position here, the time is 1,02 seconds. The time to hit the ground. 1,02. So that's the time it took now for the ball to hit the ground. So is 1,02 seconds. Is 1,02 seconds. So we're done with this guy. Now, say now, calculate the time it took the land. Okay, is this one. So well, on this part now, calculate the height from where the object was thrown. Okay, so from this one now, you're having now two options, that is as to go. Remember, once you are given the velocity versus time graph, you can calculate now then height. You can calculate the height using the equation of motion, or you can use the graph to calculate the height again. Okay, so that now we'll do this one using two methods. So, okay, so for this one, calculate the height from when the object is being thrown. Okay, so if we're to use now the equation of motion here, that means now I want our delta y. Okay, want our delta y. So you can choose the second equation, which is v final squared, which is equal to v initial squared plus 2a delta y. Then want the delta y here. Okay, then also you can choose the third one, delta y v initial t plus half a t squared. Okay, you can also choose the fourth one, which is given as v initial plus v final divided by 2 all multiplied by change in t. Okay, so any of these two equations that could work in calculation of that delta y, Okay, so let's rather use the third one, this one. Let's use this one. Okay, so if I'm using that one, let's see here, we're having delta y, which is equal to v initial t plus half a t squared. Okay, so let's see in substitution. So our initial velocity is given to be 10. Then our time, we just calculated that one to be 0,2 plus half into our a, or acceleration there, is 9,8. Okay, then the time also is 1,02 all squared. Okay, then now our okay, let's choose now the one of delta y, which will be given as v initial t plus half a t squared. That equation calculating of y. Then the initial velocity is given as 10. Then our time is given as 1,02 plus half our acceleration is 9,8. Then our time is 1,02 all squared. Okay, then now let me punch our calculator here, so that is to get the answer quickly. Once we get the answer here, it's supposed to be, or it will give us 15,31 meters. It will give us 15,31 meters. If we're using the equation of motion to calculate the height, and also this height now is positive because downward was chosen as positive. So, and we use our v initial there, that's 10, from the position that is now it is first thrown as our initial, so that now the height is going to be below. So hence now it is positive because we took downward as positive. So that's another way that is now you can calculate, that is the delta y. And also you can use now the area under the graph. You can use now the area under the graph. So if now we're looking at the area, if now let me use a different pen. If we're looking at the area under the graph, so this is the shape that we're getting here. This is the shape that is we're getting. So that's the shape of a trapezium. Or you can also just do this guy, so that now you go to the one that is you're most familiar with, that is a triangle, the top part. Let me use this one, the blue one. That is the top part here is the triangle, but now the bottom one is your rectangle here. Okay, so that means now the area in total here is made out of these two shapes, the triangle and also then the rectangle. Okay, so now from here, let's calculate the area here. Let's start with the blue part first. So the area for a triangle is given as half base times height. Now let's do the substitution. Half into, then the base here is given as 0, is 1. Sorry about that. It's supposed to be our time here. That is, it's supposed to be this part. That is our time. So that part there is given as 1, 0, 2. Then our height is given as this guy. So that is from 10 to 20. So the height is supposed to be 10. The height is supposed to be 10. Then we're supposed to get here, that is, we're supposed to get, if we're punching that, after then the 5, then we're supposed to get, that is 5,02 meters. We're supposed to get, that is 5,02 meters. We're supposed to get 5,02 meters. Okay. Now from them, from that, we move to the area of a rectangle, the red one. Let me use a red pen so that we can be able to see. That is the area, that is length times a breadth. So the length is the longer side. So the longer side is given as 10, multiply 10 by the breadth is given as 1,02. The 1,02. So here we're going to get approximately, that is 10,02 meters. 02 meters. Okay. So now in calculating of that delta y, here, that now must add all these two areas, because we said that now that height is represented by the area under the graph. So the graph here, we saw that now we're using two ways here, and that now is going to be, let me call this one area 1, then this one is area 2. So it's going to be area 1 plus area 2. So that is going to be give us 5,02 plus 10,02. Okay, so this one is going to give us, that is 15,04 meters. Yeah, okay. Almost is one and the same, just a matter of rounding here. Okay, so we're supposed to get that. Mean that now we can calculate that is in two ways. Remember, that is now if you are having, that is a graph, or the graph is presented to you. So an examiner, they can also ask you now use the graph to calculate without using the equations of motion. You calculate something that is now a height. That means now you must use the area and the graph. Calculate the acceleration, then you must use the gradient on that. Okay, so I think now we've covered that. Also, we've covered the area. This one, the area between the time x and the graph. So that the one that we've done here, this one and that one here. Okay. So the gradient, okay, the gradient of the graph. So now let's look at the gradient of the graph. So now, if we're to say now the gradient of the graph, let me use different column. So this one is our point number 1, then this one is our point number 2. So here we're having the time. Okay, so we're having those 2 points. So as you know, that is the gradient is given as y2 minus y1 divided by x2 minus x1. Okay, so now on y2, okay, we can choose y2 there to be 20 minus then y1 to be 10 divided by x2 at 20, then our x is given as 1,02 minus then okay, so at 10 the x1 there is going to give us 0. X1 is going to give us 0 again. Okay, so if we can punch that one on a calculator, then we are going to get, that is 9,8 meters per second squared. Per second squared. Per second squared. squared. Okay, so that means now this one is giving our G, the gradient of that graph of a velocity versus time graph is going to give you the G, or your acceleration due to gravity, Okay, so that means now also we're done with that part. Okay, so we're done in calculation of the gradient on the graph here. Now the last part now in drawing of the corresponding position versus time graph, okay, and drawing of acceleration versus time graph. Okay, so that's the last part. Let's quickly do that. Okay, so P versus time versus T. Okay, then on the time axis here we're having T, then we're having P, that is in meters. Okay, so from that graph, and the height that is it was thrown from, it was given as 15,3 meters. Okay, then the time it took to reach the ground, it was 1,02. Okay, so also our graph is from there until it hit the ground, So this one is going to be our position versus time graph. It's supposed to be from this particular scenario, here. Okay, then now let's quickly go to the acceleration versus time graph. The last part, acceleration versus time graph. Then we're having that is a positive here, that is 9,8, positive 9,8 here. Then on this side, on the y-axis, we're having acceleration in meters per second squared. Then on time axis, we're having the time in seconds. Okay, so now we took that is downward as positive. So since we took downward as positive, so an acceleration is also going downwards. So it's going to give you a nice straight line like that. Then at a certain time, then at 1,02, then the graph hit the ground. Then the ball hit the ground. Then the ball hit the ground there. Okay. So so we have come to the end of our lesson. You can leave your questions on comments. Don't forget to leave the name of your school so that we can give a shout out. Please share, recommend, and subscribe on our